Hello everyone, getting started with a PDAP part 2. In my previous PDAP video, the focus was more on the data engineering. I explained end-to-end integration of a big data, Hadoop, Kafka, Spark. Today, my focus are more towards the data science machine learning. So, what is PDAP machine learning workflow? PDAP provides a platform for a data science and a developer to train and build the various machine learning model. It offers the instances backed by the environments integrated with a Jupyter notebook Spider to help in every stage of a data science life cycle. It provides the optimized inbuilt algorithm along with the support of external framework that can be operated on a large amount of data in a distributed environment. So it has an inbuilt algorithm which you can refer for a further evaluation. Why to use the PDAP machine learning workflow? PDAP is used in an entire data science life cycle. It ranges from a data cleaning, preparation, pre-processing, feature engineering, evaluation of the model. Machine learning is a continuous process. PDAP facilitates it's through the interface and model retraining with a new data. PDAP helps the data scientist to focus more on the interpretation part rather than the coding. It is easy to build, train, test, and validate the model. PDAP gives the provision to choose the inbuilt algorithm or customize your own algorithm. There is no need to import the libraries, all are preloaded with a PDAP. So we have installed all the necessary drivers and configure the libraries. We just need to choose the algorithm. If you don't want to choose the inbuilt algorithm, you can choose your own machine learning algorithm. Just registered it with a PDAP, and it gives the feature of a plug and play. So PDAP is a modular framework. So what is a modular framework? So data science is having a different life cycle, right? So each life cycle we had made it as a module, and you can just develop that module, you can just configure that particular module and execute it. And if you don't want to do it in a PDAP, and if you have a offline uh, a model which is sits outside the PDAP environment, you just bring it inside through the upload facility and execute the model. So that is a model of framework. This is a PDAP life cycle, more similar to the data science life cycle. It imports the data from the multiple source, from Hadoop, from Excel, delimited files, and RDBMS database. After that, it splits the data based on the ranges slider, which I'll show you in the demo. And then we have a several stage of a cleaning. We have imputation, then do the feature scaling, anomalies treatment, feature selections, right? And after that we'll train the model, and if we'll see the results are not as per expected, after testing that particular model, we'll again go back, because it is a continuous process, and do the imputations and see how the data can be tuned so that our expectation of the model would be more accurate. And the final step is the validating the model on the unseen data, so that we can send it to the users, or for a UAT to check or to make the user feel the confident on that particular model, right? This is a PDAP AutoML. This is a separate workflow which I'll show you in the next video. This is just a glimpse. I have kept it so that you would be knowing what actually the AutoML. We have just automated the end-to-end data science lifecycle to the real-world problem. Automated all the stages of a data science lifecycle, like training, cleaning, feature engineering, outlier detection, and the best part is that we have chosen the machine learning to choose the best machine learning algorithm. It will give you the performance metrics which will help you to find out which machine learning algorithm needs to be the best for this particular data sets, right? So let's start it with the demo part of a machine learning workflow. Yeah, so this is the PDAP. You can see the glance of the PDAP framework. So last time we have gone into this data services part, wherein I have shown you the capability of a data engineering site, Kafka, real-time streaming and all. Today I'll be more focusing towards the data analytics part. So here, first of all, I'll let you know what is machine learning workflow and AutoML. AutoML I'll be showing to you in the next video. So this is the data analytics part, and this is a workbench for it. So first we need to split the data, we need to inject the data from the different source. So importing the data from the different source, like from the delimited file, Excel file, we have a rdbms, and from the Hadoop framework, and this is a model classification target, a primary key which can be removed because it would not be helpful for evaluating the models or to train the model, right? After that, we need to split the data, and we have an EDA. We can impute, scale the feature anomalies treatment, and the feature scaling. Once all this thing would be done, then you can go ahead with the training and test the model, and finally go ahead with the model validation. So let's start it with a demo part. So this project name, because whenever you are creating a model inside this PDAP, it will automatically create a workspace for a separate user. So there you will get a chance that a multiple user can work on a similar project, or the everyone can work on a different project. So different workspace would be allocated to the each resource. So this is for the demo, so I'll show you the demo. So project name, I'll keep it as a demo. This is the classification model which I'm showing it for a demo, and then the target variable name. So this is a target attribute name which you need to give it, whether the customer is responding or not responding, that particular name. And in my data set I have a customer ID, right? I'll choose for demo purpose for a delimited file, and the delimiter is comma. I'll choose the file. This is a delimited file, right? So I'll choose the delimited file and then upload the data. So data has been uploaded. So it will show the first 5 records of a data frame, just to give you a summary, and then after that if you'll see the feature summary, which will give you a count, unique, top, frequency, mean, standard, and the quantile information for each attributes, right? You can have a glance of what all the target variable you are having it, and which one is the categorical variable, which one is a discontinuous variable, and the discrete variable. Right, and then this information would be used, right? Like this is a categorical variable, gender, occupation, and the age bucket is a categorical variable, and it will give you a pictorial representation of the categorical variable, which will give you a glance of, okay, this much of a data set we are having it, and whether it is biased or not. And this will help you out giving the distribution, like 71.4% of a gender is male, right? And 1% of the whole gender would be the other, which is unknown, so you can impute it accordingly. Similarly, this will give you a frequency distribution, and then the pictorial representation of a numerical variable, which will give you a idea of which of the attribute is having a normal distribution and which of the attribute doesn't follow the normal distribution, right? So this will give you a idea about what kind of a data set you are having it, and then you can save your data set, right? And as a pickle file you will save it, go for the next, and then go ahead with the data split. So here the split part, this is a range slider. You can split the data from 10% to the 80%. I'll keep it as a 70%, and you can do the choose any one of as per your own convenience, and then split the data, right? So once the data has been splitted, it will give you the training data set, test data set, validate data set. You can just see the data set. It will also give the frequency distribution. If you see, there are around 13,396 of a non-responder and 604 for a responder. And the percentage distribution you can see in a training data set that a 95% of a data is non-responding it, and 5, so get an idea about that this is imbalanced data for which we are working on, right? Similarly, you can see it in a testing data set, this frequency distribution, as well as in a validation data set. Right, and it will give you a recommendation. PDAP will give you a recommendation. Yes, sampling is required. It will say yes, the sampling is required, and then if you'll choose yes, it will automatically do the sampling based on the sampling without replacement, right? And then do the submit. Now you've seen the sampling has been done, and for in a training data set, now the frequency distribution is almost 51 to 49%. So this will help you to get a better result if the variable is imbalanced. Now go ahead with the next part. This is the exploratory data analysis. Here you will choose the project name, the target variable, you know that is a target, primary key was customer ID, the number of records. It will help you that the first 5 records, first 10 records, or first, so if you want anything, I'll give you 15 as of now. And then you need to upload the data which you have sampled it. So I have this demo train sampling pickle file which has been automatically created when you are doing the sampling, the initiating the EDA part. So you'll see, because we have given a 15 number to display, the 15 top 15 rows being extracted, and you can just visualize what kind of a data set and what kind of a data we have, and the feature engineering part would get started. So this is very interesting part, and it would always help the data scientists to understand the data. So this table is really helpful. So it is in a single click you will be able to get detailed information about a data set, like this gender is a categorical variable which we have seen previously, and then it would have 3 categories: female, male, and others. The female, the count, what is the count of female, what is the count of male, and what is the count of others, and what is the event distribution. Like if you'll see over here, 42% of the female belongs to the responder category, while the remaining 57% of the female belongs to non-responder category. And this is a distribution event, like 19% of the female is from the total data set responding category, and 27% of the total data set belongs to female category, non-responder category. And we'll calculate the weightage of an event and the information value of each category. So if you see the categorical variable, and the same thing would happen in case of a break variable for a continuous and discrete variable. So here it has been done through the rank ordering, so bucketed into or deciled into the 10 buckets, and then the information is being retrieved from it. The data scientist has to read it thoroughly, visualize it internally, and then understand what kind of a data set we have, and based on that it will start what kind of imputation we need to do it, right? So this table is really very important, and a single click you'll get all the details. And this is a information value, right? At a first glance itself, without doing the imputation and all, you will come to know, okay, which variable are more significant towards the target variable. If you see over here, holding period, so this is a loan data set, right? That how many people when the customer has approached the customer, how many people have responded and how many of them are not. So if you will do the hypothesis testing also, you will come to know the person who will do the more transaction and the money would be more closer to the bank and would like to take a loan from the same bank, right? Rather than going for the other bank. So these are all the interpretation or the inference we can get it out, but this is more focused on the technology now. And even this is the frequency distribution of a categorical variable, and now the null value. So here it has given the information that occupation of a categorical variable is having a null value, and the count is 4500. approximately. And now this, if you see, this is a recommendation part. It will give you first an idea that occupation is a categorical variable and the null response rate is 4559, and the total percent of a missing value is 30.65. And what recommendation it gives is either you can replace the null value by the mod value, or you can merge the missing category with the nearest response rate, and that is the best part of doing it. If you'll see the occupation rate over here, uh, if you see here, this is a null value, right? If you will get an idea what is response rate of the event, right? It is around 50% of a response rate. You can choose which one is a 50% over here. See, the professor is a 50% of an event rate. So if you mix it, your data set would be obvious. So you can replace all the null value with a professor. Most probably people are changing it with a, or replacing it with a mode value, but this is another kind of imputation also you can do it. So and replace it with a missing or delete that missing value, so you can choose any. So for me it is best to choose the second one, which is replaced with a null value or replace it with a response rate category. So once I'll submit this, so it will impute the null value imputation, and if you will have a glance of it has done that, and then the pictorial view of the categorical value after the imputation. So this will give you the histogram, okay, how much the value is, and this is a pictorial representation of that. And now coming up with a discontinuous variable, even it says that holding period is having a 956 null count value. The same kind of information is being given over here. Now the recommendation, it says like the holding period, you can replace it with a mean value, or you can replace it with a median, or you can replace it with a mean, median, and with the mode value, right? So that is a recommendation. You can see the data above which I have shown you, and based on that, so, and it has also given that okay, the nearest response rate, you can replace it. The missing value rate is 48.6, and the nearest response rate is 14%, 47% of a 14. So the holding period is 14. uh, that in that bucket the response rate is 47, so you can replace all the null value with a 14. So this kind of an imputation is, so I'll also choose this one as a 2 and then submit it, right? So for a categorical variable we have done it, and now we are doing it for a null value for a numerical value imputation. So now this is done. If you see, this is done, and again see the revised pictorial representation, and you will just have a glance of it, and then again it calculates the weightage of evidence after the imputation, and you can see previously it was a holding period, right? The information value. Now after the imputation it will tell, okay, number of a transaction. So that's how the imputation works. If you do the imputation, you will get a actual which one is more significant, right? So once then this would be done, then you will check all the numerical value, whether the data is of each attribute is normally distributed or not. So I have used a certain algorithm like Shapirovic test, K2 test, and the Anderson Darling test, and even from the pictorial view also you can see none of them are normalized. So by doing this test we can come to know, okay, our data is not normalized, and we can save it as impute, right? Now go ahead with this one is done. Now the feature scaling would be required. You'll just choose customer ID. There we have a mix max, min max, standard scalar, robust scalar, normalization, and the weightage of evidence. So you can choose anyone. For a demo purpose I'll show you the normalizer, and you can go online and see which one is the best one, and what is each min max scalar means what, and when we have to do it, right? So we have a certain formula, like in case of a min max scalar, we have the variable which is we have to subtract it with the min value of all, and then subtract it by the maximum by minus minimum value. So we have a certain formula. In normalize normalizer, the distribution will have a value between -1 to 1, right? I'll choose, I have chosen the normalizer, and see, this is before scaling, and after scaling you can see all the data set is being normalized, right? And even for the categorical value, it has done the label encoding. So once scaling has been done, I'll just choose the demo underscore scale. Oh yes, it has predicted, right? Now save and next. It will go to the next step and see outlier detection. So again, the outlier detection, we have this many algorithm to choose the outlier detection. If you see, that's histogram. This is the unsupervised method which assures the feature independence and calculate the outlier score by building the histogram, like the isolation forest. If you see this, in this method, data partition is done using the set of trees in previous anomalies store, looking at how the isolated the point is in the structure. And this episode, you might have heard about all this, so I'll choose anyone as of now. uh, I can choose feature bagging. Feature bagging, it first construct the n subsample by randomly select a subset of features and then providing a score by averaging it out the base detectors, right? I'll submit it. For a feature bagging, yes, it will create a subsample and it will create a lot of trees, so it would take some time. And by the after that, it will calculate and aggregating the result, and then give us whether it is an outlier or not. All right. This will give you a result that it identify 520 outlier out of 11,366, whichever, because it has shown the first 10 records only. Which one value is 1, it will be considered as an outlier. So as you all aware that an outlier is of two type, univariate and a multivariate, right? In univariate can be found when looking at a distribution of a value in a single features, while in a multivariate can be found in a and dimension space. The feature bagging and all is a multivariate. It calculates or it evaluates the result based on looking each attributes of a data test rather than looking only the single attribute. The interquartile range, if you see this one, the last step, it is a univariate which checks if okay in the age, if there is only one outlier, then it will calculate it based on the box plot or interquartile range. There is a formula q3 minus q1, and based on that it will check, right? But it would be most useful for a parametric data set, but though our records are not following under the parametric, it is not normally distributed. That's why we have not gone for a IQR. That is an outlier detector, and then we can save this piece as a demo outlier detector and go for the next. Now the outlier detection is being done. Now go ahead with the feature selection, right? There are a lot of way we can select the feature, what all the features are important, what all the features are not important. These are all the technique which we can use. As of now, I can use, like, we have an information value, we have a VIF, we have an extra tree classifier. As of now, I'll choose all, so that you will get an idea about the performance metrics, right? If you'll see, for each attributes, each algorithm has given the certain score, and you will need to understand this score, and based on that you will aggregate the score and you will see which of the variables are not significant. Like in case of a recursive frequency, this one RFE, recursive feature elimination, this is using a linear regression multiple times for each attribute. It eliminates each attribute and select for the others. This feature says that okay, if the value is less than 3, then you can choose it as a significant attribute, otherwise you can choose it as a insignificant. Like it gives that a age bracket is not significant and the gender is not significant, right? We have a correlation from the random forest, we can choose which tree was significant and not, right? and based on that you can choose whether you need to remove certain features or not. Yes, in this, for the demo purpose, yes, we need to remove it, and this will give you a result like okay. So this is the whole variable which we want to choose it, right? So here we have eliminated the age bracket and the age, right? So we'll select that. You can choose anything, this is just for a demo purpose. You can choose any, and based on that it will give a data set, remove the features which is not significant, and then give the result. Now the feature scaling has been done. You can save this particular module and then go for the next part. And now after feature scaling, you need to train the model and test the model, right? Again, this is the k-fold cross validation, wherein you can see the data set is being divided into 10 part and then do the cross validation. And these are the top 5 algorithm. You can choose the other algorithm also, you can plug and play. That is a 1-minute job for this. This is just for a demo purpose. And you can choose all algorithm also, but it takes some time. As of now, I'll choose the all. And at the time of an split, we have divided the data into the training data set, test and validate. So I'll choose the test pickle, right? And previously we have done the normalize scaling as a normalizer, and then if you'll see, we will train, test and check the model. I click, and the result, it will take some time, though it will do the logistic regression, support vector machine, naive Bayes, random forest, XGBoost, and then create a matrix out of it. Yeah. So after selecting this all, if you see, this is a trained data set and this is a test data set, and the performance matrix has been created. So we have a certain these are all the algorithm which we have chosen it. This is the feature selected. We'll get a true negative, false positive, false negative, true negative, and we have an F1 score, sensitivity, specificity, precision score, accuracy, AUC score, and so there are performance model we have evaluated for this. And based on that, you will choose, like for a banking data sector, they will see how to minimize the false positive and all, right? This like care score, which helps you to identify whether our data is properly evaluating the responder event with against the non-responder event, right? So based on this, it has given us certain performance metrics, and the top 5 model based on the accuracy, the best F1 score out of these two more 5 models, the best recall, sensitivity, and then based on that it will also choose the best model. Based on this, it says that the regression best logistic regression is the best with the KS scores 94, accuracy 92%, right? If you like the score, then you again go and validate the model for an unseen data set. So you need to select the project for which you are going to execute it, and then uploading the validate data set. So this, at a time of an split, we have segregate the data and then upload the trained model. So if you see, when we have run the modeling, that time this folder has been created and model has been, so this is a logistic regression NB. So you can choose any to choose it. You can choose any of the model which has been saved physically, and you can choose any of the model and see which one you want to use. So let's XGBoost, and you can see the score, what score it is giving, right? So it is giving 90% or 91% for on a unseen data. So it looks good, right? You can also choose logistic regression. Over there it has given 92%, right? So here it is also giving 92.68%, right? So based on that, and if you'll see that, okay, no, this is not right score, you can again go back. As I told you that this is a modular framework, you can again go back and do the any other, like if you want to again do the feature scaling. Previously we have done the normalize feature splitting. This time you want to do the standard scalar. So suppose let's give an example for a demo. uh, Choose the appropriate field. I'll just choose 5, and this is the input. We have done it, and again click submit, right? So here the uh, normalization is being done based on the standard scalar, right? And then again go ahead and check for this. So it is a continuous process. You need to go and check to get an expected result, and so that your model would be more appropriate. So that's all for this video. Next video would be more on the AutoML. What all things what we have done it over here is manually selecting. It is a single click ML, and it gives the best result. I will tell you more in more details what AutoML it is, and because we have chosen the machine learning to choose the best machine learning, right? So thank you all. If you like this video, give your feedback below, and thank you.